Let alpha be a positive real number and f r maps to r and g alpha comma infinity maps to r be the function defined by fx equal to sine pi x by 12 and gx equal to a function 2 ln root x minus root alpha by ln e power root x minus e power root alpha. In the question it is given that alpha is a positive real number. We need to find out the value of limit x tends to alpha plus f of gx. Now you see that fx is definitely a continuous function. Fx is a continuous function because it is sine function, sine pi x by 12. So it must be continuous. And we know that when we calculate limit of a composite function, if the outside function, that is f, is continuous, then I can transfer the limit inside the function. That means in this problem, we can write limit x tends to alpha plus f of gx, that is same as f of limit x tends to alpha plus gx. I can transfer the limit inside the function because the outside function is continuous. Now let us concentrate on this limiting value. So we need to calculate limit x tends to alpha plus gx. Gx is what? 2 ln root x minus root alpha divided by ln e power root x minus e power root alpha. This is the problem that we have. Now let me do one thing. Let us keep the numerator as it is. So limit x tends to alpha plus numerator as it is 2 ln root x minus root alpha divided by denominator, let us take e power root alpha. This factor if you take common from the two terms, so it will be e to the power root alpha into e to the power root x minus root alpha minus 1. This is what we are going to have, right? Now here if we apply log property to split it up, then this is going to be equal to limit x tends to alpha plus numerator as it is 2 ln root x minus root alpha divided by ln e power root alpha, that is root alpha plus ln of e to the power root x minus root alpha minus 1. Now closely observe that as x tends to alpha plus root x minus root alpha, what is happening to this factor? Root x minus root alpha, that is tending to 0. As x tends to alpha plus root x minus root alpha, that is tending to 0 plus. That means since this is infinitesimally small, so that means I can approximate e to the power root x minus root alpha as by approximation we can write it as 1 plus root x minus root alpha. This is approximation. We know e to the power x is 1 plus x when x is very small. So in this case root x minus root alpha is very small. So I can write it as 1 plus root x minus root alpha using approximation. So in place of this, if I substitute 1 plus root x minus root alpha and one more minus 1 is there. So what will be left out with? Will be left out with root x minus root alpha only, right? I am replacing this by this, so this 1 and this 1 will be cancelled out. So now if you closely observe, you see that in the numerator you have something, in the numerator you have 2 ln of something tending to 0 plus divided by root alpha, which is a finite positive value, plus ln of something tending to 0 plus. And these two quantity, they are same. They are approximately same as x tends to alpha plus. And what is the tendency of ln 0 plus? We know ln of something which is tending to 0 tends to minus infinity. So we can say that these two terms, this term is tending to minus infinity and this term, this equivalent term is tending to minus infinity. So when they are tending to minus infinity, so what we can do is that this small finite value can be completely neglected. And ultimately we need to compare these two values in the numerator and denominator. So very simply we can say after neglecting this term it will be 2 into something tending to minus infinity by the same tending to minus infinity. This ratio is equal to 2 in the limiting sense. So this particular limit value that we have calculated to be 2. So we'll proceed with the problem. So this will be f of 2. F of 2 means we'll substitute x equal to 2 sine pi into 2 by 12. That is sine pi by 6. So answer is going to be 0.5.